When you solve problems with inverse trig functions, for example, inverse sine of 1/2, it's really similar to when you solve problems like sine of x equals 1/2 with an extra step at the end. So if you don't know how to solve problems like sine of x equals 1/2, make sure you see the link in the description below, and that's where I explain how to do those types of problems. For this video, I'm going to assume that you already know how to do those, and I'm going to go on from there. So when you solve sine of x equals 1/2, you end up with pi over 6 and 5 pi over 6. But with inverse sine, you're only allowed to have one answer, and I'll show you why. Here's a sine graph. It does not pass the horizontal line test, meaning if I draw a horizontal line, it hits the graph more than once. So we need to restrict it so that it does. And we can restrict it from negative pi over 2 to pi over 2. Now, because it passes the horizontal line test, the inverse is a function, and we can solve inverse sine problems. We restricted it from negative pi over 2 to pi over 2. We could have restricted it from pi over 2 to 3 pi over 2, or any other interval where it passes the horizontal line test, but mathematicians a long time ago decided that it was going to be negative pi over 2 to pi over 2 specifically, so that everyone would be on the same page. So we can restrict it from negative pi over 2 to pi over 2. And now if we solve, for example, inverse sine of 0, looking for all the angles that give you a value of 0, instead of having multiple answers, we will only have one within this interval. Cosine, same thing, we need the inverse to be a function. So if it passes the horizontal line test, the inverse will be a function. We can restrict it from 0 to pi. And then tangent, we can restrict from negative pi over 2 to pi over 2. Now the horizontal line only hits the graph once. So here's all of our restrictions. And in my next video, we'll solve some inverse trig problems.